Good afternoon, everyone. Welcome to another week of Tech Talk. The boys are back, and we also have Jay from Eno Supply over in the US joining us. Mike, tell us why we need to bring extra reinforcements in today. What are we talking about?
Extra reinforcements, because if we're talking about the extra reinforced cap that can be on top of the concrete out there when we approach it, I wanted to bring circle back, and I think we've covered this topic once before, but like some of our topics, we like to circle back from time to time when it becomes a bit of something out there that's coming into us from the customer base, I guess, and that is these hard caps that we're coming across, and how to tackle them, where to start, and the best way to approach them, I guess. But why don't we lead straight into Jay? Jay, is this something that only happens in Australia, do you think, or?
I got probably 3 or 4 calls this week with people dealing with different types of, very slick troweled, hard capped concrete. So it's common everywhere. It's the same here as it is there.
Concrete is the same here as it is there.
Believe it or not, yes, it's the same recipe even.
All right. So this is a relevant conversation anywhere.
Yeah.
So what's the problem with hard capped concrete then? What are people calling up for and asking for assistance with?
Getting through it. I think a lot of times what they're fighting are the 2 common things that are going to be an enemy to a diamond tool, which is texture and density and heat, right? So when you're dealing with something that's really dense and has a high concentration of that cement paste on the surface, and is also very smooth, you need to start generating a texture to be able to cut through that cap to then get into some of the softer materials. Another thing that can happen is it can vary a lot. Like a lot of guys will show up to a job site and go out and bring out their Mohs hardness tester and scratch the slab and be like, oh, it's scratching at an 8. This is going to be, extremely hard concrete. So they'll bring out their soft bond tools, put them on, get through it. But as soon as they cut through that cap, the story completely changes. You can be into a lot softer material and then sort of smoke a set of tools really quickly if you're not paying attention. So it doesn't necessarily mean if the cap is hard that the whole concrete's going to be hard throughout, but it can be a pain to get through it for sure.
So when the contractor gets through the cap and it starts to cut very quickly, does that Mohs tester come back out again?
No, it goes right back in the truck, and it usually it's like, I swear, it told me this. What do you have to say about it? I say, go ask the Mohs test. I don't know. But yeah, it doesn't come back out usually.
Sorry, just pet hate of mine, that tool. But for the very reason that you mentioned. So
Gives you a little tiny bit of detail, not completely, right? So we might face some different challenges once we get past the cap.
That's what I was going to lead into. So we've got a few different issues to be tackling with. One is the very hard finish, and then we're getting into what is often very, very different materials underneath, or at least behaviour of the materials underneath. Milan, I know you're a tool guy. What's your go-to on a hard cap on top of some medium to soft or coarse material concrete underneath? What's your tip? Tooling
I just
tip.
did a video the other week about this, didn't I? Check it out somewhere in the Cloudverse. No, basically, my combo when I come across a slab like that would be to run a combination of 2 different bonds, and it's usually a soft and medium bond of the tool. And why that would be is basically the soft tool is just going to scratch up and remove that cap for me. And once I'm in the softer materials, the medium tool is then predominantly going to take over. Not like they wear at different rates, but it's just going to slow the wear down of the soft. So the 2 tools are going to complement each other and work more productively in unison than just using one grit where you get excessive wear, bond, or the other way where you're not getting the productivity that you need. So finding that right balance between 2 bonds, I often find that works well for me.
Just on that, mate, you mentioned it, but you would run the same grits, just different bonds?
Correct, yeah. Same grits, usually 30 grit, and for the scenario Josh mentioned, it would be a soft-medium combination for me. Whether it'll be in the rocks range or it'll be, zigzag/rocks, depends.
And when we're talking about, addressing the top and then cutting what's underneath of it, What kind of depth are we talking about here, Milan? Is that combination working?
Look, I mean, obviously this conversation is about full aggregate exposure, and we always talk about when we want to do full aggregate exposure, we want to do it in one pass. So we're looking at about 5, 6, 7 mil in some cases, in depth that we want to achieve in one pass. So we are taking off significant amount of material. So if you're using tools that are too soft, when you're taking off that much material, creating so much leading edge, they're going to wear away quickly, right? So that's why we're using a medium in there, because we're removing a lot of material really fast.
I like it.
And speaking
it's called a Millsy combo. If anybody's wondering, just check it out. It's on Insta somewhere.
And speaking of tooling, Tim, what are your thoughts?
Well, it's interesting because I had a similar conversation on this topic this week, but it was more about a contractor that needed to bring a floor in an area down by about 20 millimetres. So I guess the consideration that I'm thinking of here is from a consumption of tooling expectation. Milan, you were talking about up to 6, 7 millimetres. Now, most grinding contractors in a standard pass over a floor might sort of be taking 2 to 3 millimetres off per cut. And, they'll have an expectation at 2 to 3 millimetres per cut what a general lifespan of a set of diamond tools would be. And let's just say for the argument, it's 300 square metres or 3,000 square feet. Just let's pick something a little bit arbitrary there. Now we're talking about taking 2 or 3 times that amount of material off the floor, and we have customers turn around and go, well, hang on, I've only got 100 square metres out of this set of tooling, or 1,000 square feet, okay? What's happened to my consumption rate? I'm normally 3 times that. Well, the reality is we're talking about removing 3 times the amount of material in one pass than what we normally do. So at that 2 to 3 millimetre of standard cut, you would normally be going 2 to 3 times over a floor to take that amount of material off. So everything becomes divided. So I guess what I'm probably just thinking about right now is let's just be clear about the expectations from a lifetime of tooling. I mean, we talked about how we can minimise or control that wear with the combos and so forth, but there still is a reality that your yield or your consumption per square metre is going to be significantly different when you're doing this type of activity compared to a standard pass over the floor. And let's make sure that there's no surprises when it comes to diamond tool life when people start applying these types of techniques to the application.
Very good point. Josh, do you have something to say?
I've actually got a question for Josh, and I think it ties very much into a point that he's very strong on in the seminars that we do, and we're talking about essentially the machine's either going to be on top of this hard crust or it's going to be through it and into the coarse materials of the concrete, okay? And we talk about there's this dual action of a diamond tool. There's the face that's literally resting on the floor, but then we've got this leading edge it's biting into that front ridge or front step that we're creating when we're talking about pushing this donut. And I think that's a really important concept, that we're basically creating a type of a blade action, or like an undercutting action, as well as a grinding action on the actual floor. And I think, is there anything that you wanted to touch on from that point of view, Josh? Because this whole balance of not having the machine up on top, skating around on top of this hard concrete, but keeping it down in that coarse material to keep those diamond tools open, which enables us to run some slightly harder bonds to control our wear. Any sort of particular focuses or techniques that our users should be thinking about?
No, I think Tim, you've pretty much given away my whole pitch, mate. Thanks. That's very helpful. Everyone have a great weekend. Yeah, we do spend a bit of time on this at our seminars, because this is where things get, I guess, even more complex, because we've talked about getting past the top. We've talked about using a combination to protect the wear and to take advantage of the soft bond, and then to protect the wear of the soft bond as you get in deeper. Now we're actually going to be pushing forward into that depth. So if we're cutting, 6 or 7 mil in one pass, there's a very good chance that we're starting to create a lip in front of the machine of several millimeters, because the machine is sitting almost stationary for a point in time. So it's cutting quite deep, and it cuts what we call a donut. And therefore we refer to that as pushing the donut. because that's effectively what we're doing through the concrete. So we've taken care of the wear from when we're cutting down into depth, but now we're going to start moving the machine forward. When we start moving the machine forward into that lip, it's kind of like when you've used a cup wheel, doing the edges, taking off a large lip, and you can either grind from the top or you can grind from the edge and grind straight into it. Everyone's got their own preferences on that. When it comes to using your concrete grinder to cut deep, this is probably the most advantageous way to do it, particularly if you have radio control machinery, because it'll just push into that lip and load it up with a whole lot more pressure on the front edge. So that front edge starts to become very, very important to us. Milan mentioned before using combos, and he mentioned using that he also likes to use zigzags. The zigzags have a really serrated type edge to them. So if you take a look at the zigzags, you can appreciate they look more like a saw, but then if you have a look at the lower grit rocks diamonds, they have some of that incorporated into them too. And the reason is because when we start pushing up against that edge, we're using more of like a saw action, and we want to increase the pressure against the edge as well as our down pressure. And that's what helps us to cut into that lip and just keep pushing the donut forward, while the rest of the tool's surface area removes the material as it's going along. So there's a lot happening under the machine. So obviously, a couple of other things then come into play. We need to make sure that our wheel speed is low enough for us to maintain that lip, because that's where all our pressure's going. We can't go too fast, otherwise we jump out of that lip and we're trying to cut down from the top down. That's always going to be harder to do because we're talking about a lot more surface area having to cut down. So wheel speed, if you've got a dual drive concrete grinder, bringing down the head speed, so the planetary speed, to a nice medium to slow rate means that the discs spend more time in one spot, really cutting down. And then, of course, it's going to be monitoring our actual running temperature to ensure that that diamond tool combo or selection is actually maintaining a good operating temperature, that they're not getting too hot and then just not cutting or just jumping out of the lip because all the speeds are too fast. So we're going to try and keep our temperature under control by keeping the speed where we need it to be. And then, I don't know, what other kind of measures can we use to keep temperature under control?
Well, I feel like it's a bit of a segue. I was going to say, I know right from the start with the first things Jay mentioned, of course, is temperature and texture. So, of course, there are some things that we can do to sort of try and help those things along. So I guess certainly soaking the slab to begin with, which is always good practice, but then also coming into things that'll help us along, like not only soaking the slab, but having some abrasives down, so that can sort of help things along. I guess going for a bit of a shameless plug, the Works Plus Cut Sick product, which of course has abrasion as well as a cooling factor as well. So by brooming that out, still soaking the slab, but brooming that out and having as much or as little grit as you like, but certainly the cooling factor as well, then that's going to help you. That's going to complement everything I guess we've just spoken about. So that was something that I wanted to make sure was mentioned, absolutely. But all good stuff, guys, absolutely.
Would any of these things work in the Northern Hemisphere, Jay?
I think so, yeah. I think the physics and all of these things are the same here. Material acts the same way. Hardness is hardness. Texture is texture. You wouldn't think it would by a lot of the conversations that we have, but it would absolutely, it would work here.
But you are running the diamond tools. You are running the diamond tools that rotate in the opposite direction to what we use down here in the Southern Hemisphere, right?
Well, no, it goes counterclockwise to your clockwise. It's a very touchy subject too. Which ways are my head turning?
It's a good one, guys. It's good to swing past this topic again, especially when we start getting those calls coming in and things like that. So I think it was definitely a good one to touch back on for sure. And of course, as always, if anyone's got any questions, feel free to contact us, or if any make any comments below, always appreciated. But yeah, good one, guys.
I'm thirsty.
That time of the day.
Oh, Jay, you can't have a beer because it's morning for you.
All right,
have a great weekend, everyone.
Absolutely. Thanks again, guys. Nice to see you, Jay.
Thank you, Jay.
Yeah, thanks for joining us, Jay.
Yeah, thanks, guys.
See ya. The meeting warning. That's the life.
That's all the credit we have left.
Let's do it. Let's go.
Let's put more money into this thing.